Welcome to the deep dive. Ready for an adventure?
Always.
Today, we're time traveling back to the Soviet Union in the 60s and 70s.
Fascinating era.
We're diving into some of their scientific discoveries, and let me tell you, some of these are so ahead of their time it's kind of spooky. Early AI, theories about hidden universes, a nationwide computer network, all before the internet even existed.
A lot of groundbreaking work happened there that's often overlooked.
Exactly. We'll be exploring not just what they discovered, but why it was so revolutionary and how it connects to what's happening in science today. You ready to have your mind blown?
Let's do it.
All right, so where do we even begin with all this?
Well, let's start with Mikhail Tsetlin. Back in the early 60s, he was already exploring learning automata.
Learning automata, what in the world is that?
Okay, so imagine a machine, right?
Okay.
And this machine, it learns from its mistakes, gets better over time, it adjusts what it does based on rewards and penalties.
So like training a dog, but with a machine.
Exactly. It's like a very early form of what we call reinforcement learning today.
Yeah.
The same principle behind things like AlphaGo or self-driving cars.
Wow. So this Soviet scientist was already on the path to modern AI back then, and most people in the West probably never even heard of him.
That's right. Tsetlin's work was largely unknown outside the Soviet Union. Much later, researchers in the West essentially rediscovered what he'd already done decades earlier.
Makes you wonder, how would AI be different today if his ideas had spread back then? But wait, you said there's a resurgence of interest in his work now?
Yeah. There's this thing called the Tsetlin machine, a new kind of AI that builds on his ideas.
Research from the 60s is powering cutting-edge AI. What makes the Czetlin machine so special?
Well, it's super efficient. Unlike traditional neural networks, which are complex and need a ton of computing power, the Tsetlin machine has a much simpler design.
Ah, so you could use it to run AI on things like smartphones or even tiny little sensors.
Exactly. That opens up a whole world of possibilities.
Talk about ahead of his time. It's amazing how an idea from decades ago can be so relevant today. But hold on, Czetlin didn't just stop at individual learning machines, right? I read something about him working with teams of them.
You're right. He was also fascinated by collective intelligence, multiple automata learning from each other. It's like a precursor to swarm intelligence, which is getting really popular these days.
So he anticipated reinforcement learning A&D ideas that are driving swarm robotics. This guy was a visionary. It makes you wonder what else is hidden away out there just waiting to be rediscovered.
Absolutely, and that's what makes this so exciting. Speaking of which, let's talk about another Soviet scientist who was pushing the boundaries of early AI. Get this, deep learning neural networks in the 60s.
Deep learning in the 60s. Now that sounds almost impossible. Tell me more.
We're going to dive into the world of Alexei Ivakhnenko, a true pioneer who was building complex neural networks when computers were still the size of rooms.
I am all ears. This is already blowing my mind. So we were just talking about AI in the 60s, and now we're about to hear about deep learning in the 60s. That seems unbelievable.
It does, right. But that's exactly what Alexei Ivakhnenko did. In 1968, he introduced this thing called the Greek method of data handling, or GMDH.
GMDH.
Yeah, and this algorithm, it could automatically build and train multi-layered neural networks.
Whoa, and we're talking like the early days of computing here.
Right, when computers were still these huge machines.
So what kind of neural networks was he building with these massive computers?
He actually built an 8-layer neural network in 1971.
An 8-layer neural network
Yeah.
in 1971.
Most researchers back then were still working with single-layer models.
It's like he was peering into the future. So he was essentially laying the foundation for what we now call deep learning, right? The tech behind all these amazing AI breakthroughs.
Absolutely. Ivakhnenko's GMDH algorithm used this really smart layer-by-layer approach for training. It let the network grow and learn organically.
Kind of like how things work today with neural architecture search, where algorithms help design the best structure for a neural network.
Exactly. He was a real pioneer in what we now call automated machine learning.
It's mind-boggling to think he was doing all this in the late 60s when most of the world was just starting to grasp the basics of neural networks. Do you think the AI revolution could have happened sooner if everyone knew about his work back then?
That's a great question.
Right.
It's hard to say for sure, but Ivakhnenko was definitely way ahead of his time.
Yeah.
His work is finally getting the recognition it deserves, though. Researchers are still finding new insights and applications for his ideas today.
It just shows you how much we can learn from looking back at the history of science.
Right. There are always these hidden gems waiting to be uncovered.
Stories that challenge what we think we know about innovation.
And speaking of challenging assumptions, let's switch gears for a bit. Let's talk about some fascinating research on visual pattern recognition from the Soviet Union. Have you ever heard of Bongard problems?
Bongard problems. I think I've seen them mentioned online, but I don't really know what they are.
They're these visual puzzles created by a Soviet scientist named Mikhail Bongard in the late 1960s.
Okay.
And these puzzles, they're designed to test intelligence for both humans and AI.
So like brain teaser games.
Kind of, but with a more serious purpose.
Okay.
Each Bongard problem gives you two sets of simple diagrams. Let's call them set A and set B.
Right.
All the images in set A, they share a hidden rule or concept,
Uh-huh.
while the images in set B don't follow that rule.
Mm.
And the challenge is to figure out what the rule is.
So it's like finding the odd one out, but with a more abstract conceptual twist?
Exactly. Bongard problems require this level of abstract reasoning and generalization that goes beyond just recognizing patterns.
I can see why those would be tough for AI.
You got it.
To solve them, you'd have to come up with ideas about the rule, test them out, and then refine your thinking as you go.
Right. And that's what makes them so interesting for AI research.
Why is that? What makes them so difficult for AI, even today?
Because they highlight this key challenge in AI, being able to understand abstract concepts and apply them in new situations.
Mm.
Current deep learning systems, they're great at things like image recognition
Right.
or natural language processing.
Yeah.
But they often struggle with problems that require real understanding and generalization, the kind of thinking that Bongard problems demand.
I've heard that Bongard problems are still used as benchmarks in AI research today.
They are.
Why is that?
Well, they're really valuable because they show us the limits of current AI systems.
I see.
They help researchers figure out where we need to improve.
Uh-huh.
Bongard problems force AI to go beyond just memorizing patterns. They have to actually learn to think conceptually.
It sounds like Bongard, like the other scientist we've been talking about, was way ahead of his time.
You what?
His work seems so relevant to our efforts to create truly intelligent machines.
Exactly. He understood that real intelligence isn't just about processing information, it's about understanding and applying concepts in a flexible and adaptable way. Now, if you're ready for another mind-bending topic, let's shift gears and explore a theory about how the brain anticipates and plans.
Okay, I'm ready to have my mind bent some more. What's this theory all about?
We're going to dive into the work of Pyotr Anokhin, a Soviet physiologist who developed a groundbreaking theory about how our brains coordinate complex behaviors.
I'm always fascinated by how the brain works. What was Anokhin's big idea?
He developed the theory of functional systems, or TFS.
TFS?
Yeah, and it was a radical departure from how most scientists understood the brain at the time.
What was the prevailing view back then?
Most scientists focused on simple reflexes, stimulus and response.
Okay.
But Anokhin argued that this model was way too simplistic.
Yeah.
It couldn't explain the complexity of human and animal behavior.
I can see that. Reflexes are important, but they don't explain how we make decisions or plan for the future.
Right. Anokhin proposed that the brain doesn't just react to things, it actually anticipates and plans for future outcomes.
Mm-hmm.
He believed that different parts of the brain and body work together temporarily to form what he called a functional system, all aimed at achieving a specific goal.
So it's like a coordinated team effort inside the brain and body focused on getting something done.
Exactly. And this idea, it makes a lot more sense than just reacting to stimuli.
Right. It's
Yeah.
like our brains are constantly running simulations and trying to predict what's going to happen next.
That's a great way to put it.
Yeah.
Anokhin even introduced this concept called an acceptor of action results. It's basically a prediction machine in your brain.
Interesting.
Before you take any action, your brain creates a model of what it expects to happen, and then it compares the actual outcome to this model.
So it's like a feedback loop. The brain is always adjusting its predictions based on what really happens.
Exactly. And this idea, decades ahead of its time, foreshadows modern concepts in neuroscience, like predictive coding.
Wow. So a theory from the 1960s is still shaping cutting-edge neuroscience research today.
It is. And Anokhin's work is finding new applications beyond neuroscience, too. In fields like AI and robotics, researchers are trying to build systems that can learn and adapt in a similar way.
It seems like all these Soviet scientists we've talked about today were exploring ideas that were way ahead of their time.
They were.
And their work is now inspiring some of the most exciting advances in AI and other fields.
Yeah, it makes you wonder what other hidden scientific treasures are out there just waiting to be rediscovered.
Absolutely. It's amazing what you can find when you dig into the history of science.
And speaking of amazing discoveries, Let's venture into a realm that might seem more like science fiction than science fact.
Okay, now you've really got my attention. What are we about to explore?
Get ready, because we're about to dive into the mind-boggling theory of mirror matter.
Mirror matter. That sounds like something out of Star Trek. Tell me more.
It might sound like science fiction, but the theory of mirror matter was actually proposed back in 1966 by three Soviet physicists, Kobzarev, Okun, and Pomeranchuk.
Okay.
They were trying to solve a puzzle in particle physics, the violation of parity or mirror symmetry.
Okay, I have to admit my physics knowledge is a bit rusty.
Yeah.
Can you explain what parity violation is?
All right, so imagine you're looking in a mirror.
Yeah.
Your reflection looks like you, but flipped.
Yeah.
In physics, mirror symmetry means that the laws of nature should be the same, whether you're looking at the original or the mirror image.
Gotcha.
But in some weak nuclear interactions, the symmetry breaks down.
So it's like nature has a preference for one side over the other. That's weird.
It is strange, and that's why these Soviet physicists were so interested in this broken symmetry.
Why were they so concerned about it?
Because it challenged a fundamental assumption about the universe.
Yeah.
The idea that the laws of physics should be symmetrical.
Right.
So to try to fix this, they propose a really bold idea. For every particle in our universe, there's a mirror counterpart in a parallel, hidden universe.
A whole other universe made of mirror matter. And we can't even see it or interact with it.
That's the theory.
Wow.
And what's even more interesting is that this mirror matter could explain one of the biggest mysteries in cosmology, dark matter.
Are you saying that dark matter, the invisible stuff that makes up most of the matter in the universe, could be this mirror matter?
That's one possibility that physicists are exploring.
Wow, that's incredible.
The mirror matter theory would explain why dark matter is so hard to detect.
Right.
It suggests that mirror matter mainly interacts with our world through gravity, which is a very weak force.
This is blowing my mind. We've gone from AI to the brain to a possible hidden universe, all thanks to these Soviet scientists. It really makes you appreciate how powerful human curiosity is.
It really does.
The drive to understand the world, even when the answers seem impossible, is incredible.
And that drive to understand led another Soviet scientist to envision a future where computers would be interconnected on a nationwide scale long before the internet, as we know it existed.
A computer network before the internet. Now that's a story I have to hear. A computer network before the internet. That's hard to imagine.
It really is. It shows how forward-thinking those Soviet scientists were. This project was called OGAS.
OGAS.
Yeah, it stood for the All-State Automated System.
That sounds ambitious.
It was the brainchild of Viktor Glushkov,
Okay.
a brilliant computer scientist.
Nah.
His idea was to connect hundreds of computer centers across the Soviet Union.
So, like a precursor to the internet. What was it supposed to do?
Glushkov's vision for OGAS was to manage the entire Soviet economy in real time,
Whoa.
gathering tons of data from every part of the economy,
Okay.
using algorithms to make decisions.
So, big data and AI-driven economics way back then.
Exactly. He was decades ahead.
Did he have specific plans for how it would work?
Oh yeah, very detailed. Remote terminals for data input, algorithms to balance supply and demand across the whole country. He even thought about electronic currency to replace cash.
Electronic currency in the 60s. That's crazy. So what happened? Did they build it?
Sadly, no.
Really?
Glushkov had the plans, even some pilot projects,
Yeah.
but it faced a lot of pushback.
I can imagine.
Ministries didn't want to lose control,
Yeah.
and funding was a huge problem.
Yeah, a project that big must have been expensive. What a shame it never happened.
It is a what-if moment in history.
Yeah.
But even though OGAS was never fully built, Glushkov's ideas were influential. He was a true visionary.
Yeah.
He saw a future where computers would run complex systems, like the economy.
So his vision kind of paved the way for our digital world today.
In a way, yes. It's a reminder that sometimes brilliant ideas come before their time. It takes a while for the world to catch up.
Makes you wonder what other groundbreaking ideas are out there, hidden away, just waiting to be rediscovered.
Exactly. That's the beauty of exploring scientific history. It's full of surprises.
This deep dive has been amazing. It's given me a whole new perspective on innovation.
I'm glad to hear that. We've seen how these Soviet scientists, often working in tough conditions, made incredible discoveries
Right.
in AI, neuroscience, even physics.
It's inspiring.
It shows that innovation can happen anywhere, anytime. And it's important to be open to new ideas, even if they seem strange at first.
Absolutely. A huge thanks to you for taking us on this journey through Soviet science. And to our listeners, keep exploring, keep asking questions, keep diving deep. You never know what you might find.